Okay, this is Algebra 2, Lesson 30. And here we're going to start talking about deductive reasoning. And some of the stuff we're going to talk about, you just got to kind of know the concept and what it means. We're not going to go into a lot of detail about the history of this, but we're going to talk about deductive reasoning first. Basically, deductive reasoning is a term that we apply to a process of reasoning from a non-reversible statement called the major premise. To a result of a conclusion that we call a conclusion. So the major premise is, it's always an if-then statement. So we go from a major premise to conclusion, and the major premise is an if-then statement. And we say it's non-reversible, meaning it goes from A to B, but B, you can't reverse, and B goes to A. For instance, this tells us that if A is true, then B is true. It doesn't say that if B is true, then A is true. Okay, for instance, if we say if a quadrilateral is a square, then the quadrilateral is a rectangle. We don't say, we can't reverse it and say if it's a rectangle, then it's a square. That would be false, since all rectangles are not squares. A three-step deductive reasoning process consisting of a major premise, a minor premise, and a conclusion is called a syllogism. So it's a three-step process. And note that the major premise can be stated without using the words if, then, and the premise, so for instance, the premise, if a polygon is a square, then a polygon is also a rectangle. It's stated without using the if, then, and the major following syllogism. So look at the top of page 135. It says you have a major premise, your minor premise, and your conclusion. Shows you the three steps. It's written like this. The major says all squares are rectangles. And the minor premise is quadrilateral ABCD is a square. Quadrilateral ABCD is a rectangle. They can sometimes be tricky, and we have to be careful. So let's consider the following syllogism. All poets are poor. Roger is poor. And Roger is a poet. It's not valid. Why isn't it valid? Because we have reversed the major premise. The premise was given, poet is poor. Poets are poor. It doesn't say if you're poor, you're a poet. So that's why it's false. Just because Roger's a poet or is poor doesn't make him a poet. So do you understand how you have to be careful? An argument is a valid argument if we reason correctly. A valid argument does not lead to a true conclusion. If one of the premises is false, consider the following syllogism. The major premise is all chickens have 3 legs. Henry is a chicken. Henry has 3 legs. So it's valid. It's a valid argument because the reasoning process from the major all the way down to the conclusion is correct. The conclusion is false, will become false if one of the premises is false. So let's consider the following syllogism. The major premise, if it rains, I would go to town. It did not rain. I did not go to town. Well, that's invalid because the conclusion is false because the reasoning process is invalid. The major premise says I go to town on days that it rains. It makes no statements about what I will do on the days it does not rain. So the conclusion I did not go to town is not true because we didn't say what I did on the days it did not rain. So therefore this is invalid. Okay? So we have to be careful when deductive reasoning. So basically you need to understand what deductive reasoning is. Just a term that we apply to a process of reasoning that's from a non-reversible statement that has a major premise that results to a conclusion. So an if-then statement that it cannot necessarily be reversed. So now we're going to talk about Euclid. This kind of gives you a background, and I'm just going to kind of sum it up quickly. I'm not going to read the whole thing, but they talk about the Western world and the Egyptians and the Babylonians, how that was the first mathematics, the Western world, but there was nothing compared to the Greeks, who were their successors. And it talks about many of the ideas and about deductive reasoning that they use. We know a few talk about Pythagoras, who we got the Pythagorean theorem, and a couple of other ones who made some major contributions to geometry. Now we will turn to page 137 and look at Euclides, whom now we call Euclid. He was a Greek scholar who probably lived in Alexandria, Egypt, during the reign of Ptolemy I, the first Greek king of Egypt, around 323 to 285 BC. He completed the work of his predecessors and expanded it on its treatise on geometry called The Elements. So basically, he stated that some facts about mathematics were true because they were true, and that their truth could just be accepted without proof. He called these self-evident axioms or postulates. And this is a word we're going to start seeing. So this is what I want you to be familiar with. You've seen axiom. If you've done Saxon, you'll see axiom thrown around a lot. But we can also associate it with postulates. And this is something you'll see in geometry. Basically, postulates are something that we just accept as true. Then he proved 460 other reasonings was logical and was based on self-evident truth. Because the reasonings was logical and was based on self-evident truth, these assertions that he proved were believed to be true even though their truth may not have been self-evident. These provable assertions are called theorems. So theorems are things that we have to prove, and we prove them with postulates. And postulates, we just accept things as they are. So let's look at a couple more things. It says, definitions are the names that we give to ideas. Definitions are not proved. For example, you shall define parallel lines to be any two lines in the same plane that do not intersect. The definition does not imply existence or non-existence of a parallel line. It just says the two lines in the same plane and they don't intersect. So we call them parallel lines. It's important to remember that all definitions are reversible. Thus, if we say, if we have a pair of parallel lines, they must be in the same plane and they must not intersect. Theorems, axioms, and postulates are not reversible. For instance, if two angles are right angles, their measures are equal. But angles whose measures are equal are not necessarily right angles, because can't you have angles with measures of 60? That's not a right angle. Right angle is 90 degrees. So postulates, axioms, and theorems cannot be reversed, necessarily reversed. Okay? So he was able to reduce the list of his postulates or axioms to 10. So if you look on the page of 136, they list them. Basically, we're going to just kind of briefly go through them. Postulate 1 says 2 points to determine a unique straight line, meaning if you have 2 points, you can connect them and they'll make a unique straight line. Postulate 2 says a straight line extends indefinitely far in either direction. And it says a circle may be drawn with any given center and any given radius. It says all right angles are equal. Yes, because all right angles are 90 degrees, so they're equal. Given a line, 5 says given a line N and point P not on that line, there exists in the plane of P and N and through P one and only one line, M, which does not meet the line N, the given line N. 6 says things that are equal to the same thing are equal. So I say if A is equal to C and C is equal to B, then A is equal to B. Okay? It says if equals be subtracted from equals, the remainder are equal. 7 says if equals added to equals, the sums are equal. 9 says figures that can be made to coincide are equal or congruent. And 10 says the whole is greater than any part. Okay? There are other postulates and proofs, but we will try and build geometric structure based on the postulates and proofs that we have here. So, we will do a few simple proofs to familiarize yourself with the process of deductive reasoning, is why we learn that, and the major emphasis on the book, however, will be on learning and using the fundamental properties of geometric figures. So let's look at example 30.c. It says we can use the 6th and the 8th postulate of Euclid to prove that the vertical lines are equal. So let's consider this figure, x, y, and then the angles x, y, z, and p. We see that x plus y equals 180, right? Because they make a straight line. So we have x, y, p, and z. So we set x plus y equal 180. And then we set x plus z equal 180. Because both x plus y and x plus z equal 180, so we can say, using his 6th postulate, that x plus y is equal to x plus z. Postulate 8 says that if equals are subtracted from equals, then the results are the same. So we subtract x from both sides, then we get y equals z. So here, the same procedure can be used to prove the equals, that x and p are equal. We have used 2 postulates of Euclid and reasoning deductive from these postulates to give a theorem. So let's look at 30.d. It says, when parallel lines are cut by a transversal that is perpendicular to one of the lines, all the angles formed a right angle. So if you look at the lesson example 30.d, you'll see on the left that all the angles are right angles. And if you look on the right, when you've got this postulate, okay, if the angles are not right angles, we have postulates that half the angles are small angles whose measures are equal, and half the angles are large angles whose measures are equal. So you see, half of them are small, those are all equal, and half are large, and those are all equal. To discuss this topic, it is customary to use only 2 parallel lines to give the angles special names. The angles between the lines are called interior. So these between these 2 lines are called interior angles. The angles outside of the parallel lines, so like these 4 angles right here, if you only had 2, are exterior. If you look at the 3, it's these 2 and these 2 are exterior angles. Okay? Angles on the opposite of the transversal, remember this is the transversal line, are called alternate angles. In this figure on the left, though, we know that alternate interior angles are equal. So these 2 are equal, and these 2 are equal. These 2 are equal, and these 2 are equal. They're on opposite sides, and they're interior, so they're alternate. Okay? In the center, we note that the alternate angles are equal. In the figure on the right, we show that 4 points of corresponding angles. Okay, so you had, I'm not going to draw it, but you had A, B, C, D, A, B, C, D. Those are corresponding angles, and then the A's are equal to the A's, the B's and B's, C's and C's, and D's and D's, if you look at the example on top of page 187. So Euclid used his postulates in deductive reasoning to develop a lengthy 4-part argument that proves that if 2 parallel lines are cut by a transversal, okay, the alternate interior angles are equal. So these are equal. Alright? And the proof is above the level of this book. So we're just going to look at the proof. It says, when parallel lines are cut by a transversal, the pairs of alternate angles are equal. So the theorem permits us to label alternate interior angles small, small, large, large. Yes? So we can extend this procedure to any number of parallel lines and cut by a transversal. So let's look at example 30.E. It says, the proof that the sum of the angles in a triangle is 180 is a simple proof that uses the knowledge that we have about angles formed when transversal intersect lines. So let's look at it. So we know what a simple triangle looks like. So let's take this one. Okay? Let's take that same triangle and let's make a parallel line right here at the vertex, and let's extend these transversals. We can call this A, B, C. We can call this transversal M and transversal N, and angle A and C. So basically the angles marked A are equal because they are equal small angles or alternate interior angles. So if you ignore this one, aren't these alternate interior angles? Yes. If you look at this one, these two are alternate interior angles. So those two are equal. Formed by the parallel lines and the transversal N. At the vertex, we see that the angles A, B, and C formed by the parallel lines and transversal N. A, B, C form a what? A straight line, and whose sum equals 180. Okay? So that's all you really got to know. Is got to understand what postulates and theorems are. Postulates are something that's just given, and it's a fact, and we just have to accept it. Whereas a theorem is proven using the postulates to prove it, and those must be proved. And then we use alternative angles to prove and show that. Okay? Do your practice problem. The code for this lesson is the number 85 on the top of homework lesson 28. 85 on the top of lesson 28.